Alright, hi there. So I want to talk about a little project that I've had kicking around in my brain for a while, and I finally implemented it. So the idea was to establish wireless communication between two machines using only light. In particular, using a pair of signal flags, these over here, and a webcam on the receiver, and conveying ASCII characters through the positioning of these flags. So here was the basic setup. I started with a Raspberry Pi, and this is very overpowered for the application. The Pi is really just sending pulse width modulated signals out a pair of GPIO pins to a pair of servos. And the servos are driving a pair of flags, these little red squares. And by sending commands to the servos, we can position these flags wherever we want. So unfortunately, I'm connected wirelessly right now from a laptop to the Pi, so that kind of defeats the whole idea of avoiding Wi-Fi. But ignoring that, I have a laptop over here which is SSH'd into my Pi, so this is just sitting on my Raspberry Pi right now, and I can run my code to drive the servos. Over here I have a laptop running some code written in Eclipse, and this code is using a webcam to look at my two flags, and as the flags move, it will track the position of them. And if you look very closely, there's a small dot in the middle of each flag that's indicating where it finds the red flag. So I'm going to run my servo code, and the first thing I'm going to do is send an empty line to the Pi, which will cause it to put the flags into their calibration position. So that's the 0 and 3 o'clock position. And once it's calibrated, I'll come over here and it's tracking both flags correctly. So I'm going to tell it to calibrate by just clicking in the window. And now it's decided what the positions of the flags are. And it's told me down here it's at the start of a word. And it's about to start receiving characters. So I can come over here and I can type a message like hello exclamation mark, and when I hit enter, the flags begin to move and they are sending out the characters HELLO, and you can see them appear in this window on the right, one character at a time. This is not a particularly efficient way to communicate. Obviously it's using a coding system that's hundreds of years old. Nonetheless, it does work, and it lets me send not just printable characters, but actually any ASCII characters, including, for example, a new line which will come out after the exclamation mark. So that if I now type another message like cool with a smiley face, and I send that out, that'll begin on the next line. So there's the C, and so on. And down here I have various debug information coming out. I know it's extremely hard to see with the color scheme, but it's showing me how it's breaking up the patterns it's receiving into each character. So there's a cool, here comes the smiley face on the end. There's a space, there's the eyeballs, and here comes the smile. So a few technical issues I ran into. The first was my servos only go 180 degrees. To use a regular standard flag-based alphabet, you need to be able to move your flags more than 270 degrees. And I didn't have servos that did that. They only move 180. And so I had to simplify the code, and basically I have a series of positions that I use to send a 2-bit quantity. I send 4 of those 2-bit quantities to build an 8-bit byte. And I also threw in a start of word just to catch framing errors. That's optional, but it gives me a little more reliable communication. So it's actually 5 flag positions to send a single byte. That's part of why it's very slow. The other reason it's slow is because the image processing is pretty slow. It takes over half a second to detect the position of the flags. And if I move the flags too quickly, it's prone to missing intermediate positions. So I'm sending the flags with a full second of delay in between, very slow, so 5 seconds per character. I tried using stepper motors, which allow full 360 degree positioning, but the steppers I happen to have weren't very reliable. Let me go ahead and send some more text. So we'll say this is a big test, 1, 2, 3, 4, 5, ... And we'll let this send its message while we're talking. The stepper motors weren't very reliable. They didn't have reproducible position if you change direction, and they were also fairly slow, although if I only need one transmission per second, it would still be a significant improvement over this, where I need 5 seconds. This is fully optical, by the way. It's not a trick. It's getting the information from the position of the flags, and if I, for example, occlude one or both of these flags, it starts to trip up. And instead of saying this is, it will lose information. It will say unknown flag pattern down here, and if I give it full view of the visual field again, it will continue, but it's lost some information. So this is a big test, so it lost stuff in the middle there, and now it's continuing with big test. So it's a bit of a self-correcting code, although it loses information if it loses line of sight to the flags. That's not terribly surprising. Future improvements: take these servos, hook them up to a gearbox so that we get a full 360 degrees of motion, and then we can use the standard code where we have a single flag position for each character. I don't know how standard flag signaling works for duplicate characters, but I have a special flag position which says this is a repeat of the previous character, so that if I want to send a character twice, I actually use 2 different flag patterns, but the second one just means repeat the previous. And if I want to send more than 2, I just alternate between the original coding and the repeat coding. So lots of details. Again, this is not intended to be practical or efficient. It was really just an excuse to put together something kind of quirky, which is doing wireless communication by way of visual observation of a pair of signal flags. And that does seem to work, slowly, but it does work. So there's the end of our big test, 1, 2, 3, 4, 5. It'll put out a new line, and the flags stop, and we're done. Anyway, that was my weird little project for the weekend. Hope you enjoyed it. Take care. Talk to you later. Bye.